Hi, I will be presenting floating point representation. So floating point representation deals with real numbers, unlike the ones complement and two's complement that deals only with integer values. So this floating point representation is useful in scientific or business applications. And we have this decimal floating point representation, or also called scientific notation. And it has form of like this. It has a mantessa and the exponent. So let's have an example. 6519.23 convert into a scientific notation. So muna siya ang iyahang scientific notation. 6 ano siya? 6.51923. Ano siya gi-transfer dere. So ano siya? 6.51923 times 10 since it's decimal, and then ang iyang exponent is 3. Kay kapila mo na siya gibalhin. 2, 3. So man siya. Ang example number 2, 0.0000391. Kani 3.91. Bali na to siya dire. No. Kani na 3.91. Sama na siya. 3.91 times 10. And then, ikapila siya. Gisbog. Since kaysa right man siya paingon, so negative. Mong negative 6. Sama na siya. Then, decimal floating point numbers can also be converted into a binary systems. Sama na yung forma. Times 2 since it's binary. And then, it has mantessa and exponent. So, in order to convert the decimal floating point into a binary floating point form, we have to normalize the number first. So, example number 3, 1344. We have to normalize it with respect to the largest number of 2. So, the largest number of 2 is 2 to the 10. Since kay ang 2 to the 11 man, 2 to the 11 is 2048. So, manglapas na siya. 2 to the 10 is 1024. So, may pinakaduol-duol niya. So, ang result niya is 1.3125. Datang ikuan. 1344 divided by 2 to the 10 is 1.3125. So, na siya. And then, kailangan pa man nato ikuan ang kaning mantessa niya. Kailangan pa nato convert into a binary form. So, i-times lang nato siya og 2. 0.3125 times 2 is equal to 0.625 times 2 is equal to 1.25. So, tayo padaplin ang 1 kani. Then, 0.25 times 2 is equal to 0.5 times 2 is equal to 1. Then, na mag-end. So, karon na to na siya i-star. So, 1344, ang iyahang binary floating point form is 1.0 1, 0, 1. So, ano siya? 1.0101 times 2. Ang yahang exponent is 10. Kani, 10 man to convert sa binary. So, 1010. So, ano siya ang binary floating point form sa 1344. So, note that once in binary floating point representation, the computer stores the value of the exponent and the mantessa separately following the IEEE 754 standard. So, floating point consists of 3 fixed-size fields. So, ano siya ang sign, ang exponent, o ang significant. So, according to the standard, naay duha ka precision. Sa single precision o double precision. So, sa single precision, ang iyahang sign is nag-consist of 1 bit and also the double precision 1 bit. And then, sa iyahang exponent, na siya 8 bits, next 8 bits. Sa double precision, na siya next 11 bits. Then sa mantessa, sa single precision, na siya last 23 bits. And then sa double precision, na siya last 52 bits. So in total, ang single precision, naa siya 32 bits tanan. 32 bits. And then sa double precision, 64 bits tanan in total. To determine the sign, so kung 0, positive. Kung 1, negative. Parehara sila sa single precision sa double precision. And then exponent bits, exponent plus naa siya 127 bias sa single precision, and then exponent plus 1023 bias sa double precision. 1023. So the bias is introduced in order to avoid using one of the bits for the sign of the exponent. So in order for us nga makasabot jud, let's take a look in this example. So 22.5, store 22.5 in double precision. So first step is normalizing the number with respect to the largest number of 2. So, mauna ni siya, ginormalize nato, 22.5 is equal to 22.5. Ang yahang largest number is 2 to the 4. So, mauna siya yahang result. Two to the 5 is 32. So, manobra na siya. 2 to the 4 is 16. So, 22.5 divided by 2 to the 4 is 1.4625. So, next is determine the sign. Since kay positive man ang number, 22.5, positive man siya. So, ang atong sign is 0. Next step, get the exponent with the bias. Since ang atong exponent is 4, and then double precision man, so ang atong bias is 1023. I-plus na nato, i-add na nato siya, then we will get the 1027. And kaning 1027, ato siyang i-convert into a binary form. So, decimal 1,027. Mato siya pwede dari siya pwede. So, ang iyahang ani is 1000000011. Siya ang binary form sa 1027. Then lastly, get the mantesa. Ani. So, nga toon na gyapon siya parehas sa binary floating point kanina. 0.40625 times 2 until makuha nimo siya. So, ang iyahang binary floating, ang iyahang double precision. So, the IEEE 754 double precision representation of 22.5 is 0. Muna siya ang sign since positive. Ang iyahang exponent, katong kaganina, muna siya ang exponent. And then, the mantesa. Sa atong ipon. Na siya ay 1 bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 20. No. Honey is 52 bits. In total, 64 bits. So let's have another example. So write the decimal number negative 45.8125 in the following forms. First, we will get the binary floating point representation of this decimal number. So, ang atong batong pinakauna, normalized. Normalizing the largest number of 2. Normalizing the numbers with respect to the largest number of 2. So, 45.8125, since negative man siya, ang atong sign ana is 1. So, 45, kung mag-normalize naman ta, pwede rin nato tanggalan sa sign. Ang iyahang largest number is 2 to the 5th. Ano siya? Ito. 45.8125 divided by 2 to the 5th. 1.4316. Ano siya? Then we will get the mantesa. So, ang iyang mantesa is 011. So, muna na siya. I-times 2 lang gyapon. So, the binary floating point of negative 45.8125 is 1.011 011 011 111 001 001 times 2 raised to the power of, since kaya itong exponent is 5 man, diba? So,